Hey everyone, welcome back to the channel. So today is the day 4 of the February LeetCode daily challenge, and we have this problem today, problem number 567, permutation in string. Yeah, so I would suggest all of you to try this problem, and if you're stuck anyway, you can continue watching. Okay, so let's get straight into it. Given two strings s1 and s2, return true if s2 contains a permutation of s1 or false otherwise. Okay, so the problem statement is pretty simple, and I think it must be clear to all. So basically you are given two strings s1 and s2. So what you have to do, like you have to look in s2 that if there is any substring which is a permutation of s1. Now I think you must all be knowing what is a permutation, right? So if ab is a string, now let me move to the explanation. I'm considering these two sample inputs. Okay, you can see the constraints. If you try to brute force, like you try to construct all the permutation and then you keep on checking for each permutation in the string s2, then it will obviously be TLE. So we don't have to do like that. So I must so first I will tell you, like, you must all be knowing what is permutation of s1. Okay, like, please ignore my spelling mistakes. Permutation of s1 will be like, it's ab, right? So one will be ab itself and then ba. It is a permutation, right? So for each alphabet there are only two possible, and we've constructed there is no other permutation, I guess. Yeah, so if the string would be like abc, the permutations will be like abc, first abc, then acb, okay, then one bac, then bca, and then cab, and then cba. So if there are three, then how many permutations we are getting? 6, right? Okay, but here we are given like ab. One thing you can note, like whatever the permutation is, the alphabets are same. Like here also there are only two, 1a and 1b, and in the second permutation also 1b and 1a. In the previous bigger string also, which we considered like abc, here let me show you all the permutations. abc, acb, bac, bca, cab, cba. So here you can see whichever permutation you consider, you can see that all the alphabets are same, like one time a, one time b, one time c. Any permutation you can pick. So basically what we are saying, that the count is not getting because in permutation we are just rearranging, we are just changing the order, but we are not replacing any character itself. Okay, so the map, what you can say, that the frequency or the occurrence of each character will be equal for every permutation of the string. One thing is clear, right? B is also occurring once, and in this permutation also 1 is occurring once and b is occurring once. So the frequency of each character will be equal in all the permutations. Okay, this is one observation. So now we have to check this, like we have to consider this s1, and we have to consider its permutation, that any of its permutation, like ab, these are its two permutations. We have to consider any of s1's permutation should be a substring in s2. We can see that here ba is present. So how we can do that? So I just now told you that the frequency of each character will be equal. So what we can do is we can just simply make a frequency map from this. We can see that in the given string how many characters is occurring how many times. Okay, like here. And one thing also for obvious, that if string s1 length is greater than s2, then there will be no answer. We will simply return false, because if the string is bigger itself, like if you have a string, s1 is given like a, b, c, d, and s2 is given you cd. So the string length of string 1 is greater by s2, so no permutation will be there such that it will be a substring, right? Because the any permutation of s1 will be of length 4, and how it can be present as a substring in s2 when the s2 length is less than s1. Okay, so this is one observation. So I told you that just simply create a map from the s1, and now like any permutation will also have fixed length of s1, like all the permutations of length of s1 will have same length. So now we will keep on going in s2, and we want substring, not subsequence. So we can basically do this by sliding in each substring of length 2, like first this one, and then we see this one, and then the next substring with length 2, and wherever the substring of length 2 comes equal to the frequency map of this string 1, that means you have found a permutation, because I just now told you that the frequency of each permutation will be equal. So we are fine, no matter what the permutation is. Like here it is AB, but we are finding the permutation BA, but I told you both the permutation will have length equal. Okay, so we will just traverse each substring of length 2, and if we find the frequency of that substring is equal to the frequency of the given string, that means we found our answer. Here also you can see, now in this case the answer is true. Now let's see this case, AB. Okay, so we go like EI, no, it's not equal to the frequency of S1. Here also not equal. You can say like here, but it is not a substring, it is a subsequence, because here this one O is also coming in between. So here there is no substring in S2, which is permutation of S1. So we just simply return false. I hope the approach is clear to all of you guys. Now I will explain you code, and one thing more, like when I will show you the code, then I will come to that point. Okay, so now let me show you the code. Wait. Yeah, so this is the code. Like I have done that, I have taken this both the strings length in S1 and S2. Wait, let me make it thicker, like here. So I have taken the string length in S1 and S2 here, and then that condition, if S1 is length is greater than S2, return false. Now we are creating the frequency map of the first string, and map 1, and okay, we have all the characters frequency stored in map 1. Now we are just for the first L1 length 1 characters, like EI. So first we go till EI. First initially our window is empty, right? So we will, like, we are considering window of 2. So first in our window EI will be present, so we are filling that in that loop. Yeah, here, so we are just filling the window in the map 2. Okay, and then we are just because we can't do like a n square approach, we can't just iterate for each substring. We are just using a sliding window kind of approach, that whenever we are considering the next element, we increase the frequency of that character, and the character we are leaving behind, we are decreasing that. So yeah, then we go till I is less than L2 for this length of string 2. We compare if both the maps is equal, that means our substring is found, the permutation is found, so we return 1. Else what we do, now the new character, that is I. So I is representing the starting of the window, and J is representing the ending of the window. Okay, so I just denotes that we have to include that, and we have to increase the count. So I just include the character at the ith position in the map, and we move to the next, and J represents the ending of the window. So we just decrease the frequency of that which is at the J character. One thing, you also make sure that if the frequency is equals to 0, you just erase that element from the map. Otherwise these map MP map 1 and map 2 won't be equal. Okay, and you just move on, like you're just sliding window approach. Then at the end also, like one case I'll show you. Wait, at the end, like consider this case. Okay, wait, when S equal to ADC and S2 equal to DCAD BCAD. So here this the permutation is found at the end. So after we are finished, like it is basically a implementation kind of thing, it can vary person to person. So at the end also I am checking if it is found at the last, it is the last window where the map are getting equal, then we then it is also we have found the valid permutation, and we return 1, otherwise we return false. Yeah, I hope this is clear. If you have any doubts, you can tell me in the comment section. I'll try to resolve them. And yeah, thanks for watching. If you like the video, please give it a thumbs up, and don't forget to subscribe to the channel.